this lesson, we're looking at factorizing by completing the square. So we're adding another tool for factorizing. To start off with the lesson, we're looking at how we can make a perfect square. So if we look at this section down here, what they've done is they've represented this whole concept of what are we actually doing sort of visually or physically, and why do we call it completing or making a perfect square? Consider this. We've got a box here. So this is a square, and its sides are x plus 3. And you can see that because it's x plus 3, x plus 3. If we wanted to find the area, well, we can break it into each of those boxes. So if we know from here to here is x, and we know from this little point here to this little point is 3, then the area of this box is x squared. This one is 3x, this one is 3x, and this one is 9. So if you simply add those together, you're going to have x squared plus 3x plus 3x plus 9. And if you combine that, we get our x squared plus 6x plus 9. So you see that we've created a quadratic from the area of a square where we have an unknown value. And that's what they've done here. And we could factorize that. We could say, well, that's just the same as x plus 3 times x plus 3, because it's base times height. So this is the height, this is the base, which in a square, they're the same. We get our square. So that's the concept that we're talking about here. Now what I want you to do is have a go at doing the same thing for these two. So try and construct a square that follows the same rule. It's almost kind of like Sudoku in a way. If you know you've got a square, you know you're going to have an x squared box. So straight away I'll tell you, you know you're going to have an x and an x. But then what do you have here and here to potentially create these other two boxes that we need? So I'll leave that with you. Have a go at that and then move on to the next section. So to solve something by completing the square, this slide in particular, I don't particularly like. I think there is a better way to explain how we do this. But basically what we're saying is, if you remember from the previous version, we talked about completing the square in the past, and completing the square was where we have like x plus 2, x plus 2, or x plus 2 all squared. If we expand that out, we get x squared plus 2x and 2x, so 4x plus 4. Or another way that we could describe this more generally, to use sort of letters, is if we have x plus a times x plus a, we get x squared plus 2ax plus a squared. So this is the key. For completing the square, what we actually did was we went backwards. We then, at the end of our last section, said you're looking for a x squared plus 2 lots of something plus a something squared. And we can then simplify that to go, sweet, that's just going to be x plus a, that we can identify straight away here, as soon as we recognize that this is 2 lots of it, and x plus a. So that's what completing the square was in the first place. How does that relate to what we're about to talk about now? Well, let's consider it. What we're doing now is trying to use this process, except that if we have something like this quadratic, we can't simplify it using the methods we did before. You can't use that simple factorization. There is no common factor. We can't write it in the form of x minus a, x plus a, where a and b are rational. They're going to be these horrible numbers. So the better way to do it is to solve an equation that looks like this. So we need the x squared plus 4x plus 1 equals 0, and then we can complete the square. So I'm going to show you how I think is a better way to describe it. In the key ideas, it talks about the trick is to add b on 2 squared to both sides. I think that's a little bit kind of confusing. It is really what we're doing, but there is another way to think of it. But so the rule is basically you're adding b on 2 all squared to both sides. And this is similar to the previous section where at first it's going to seem like that's really weird. Why am I just adding some random value to an equation? And in particular, if I'm adding it to both sides, it means I'm actually not doing anything because I can move one across and they'll subtract each other. But that's the point. I can't just change an equation. I can add things to it, but I have to add things to the other side to balance it. So let's look at a better example. In this case, solve for the exact values of x squared plus 4x plus 1. If we use that perfect squares rule, it says, well, what is b onto all squared? Well, a here is 1, b is 4. So this is going to be 4 onto all squared, which we can simplify. 4 on 2 is just 2, but keep the squared. The reason that we're keeping the squared is because we want it to look like something in particular. Now I can rewrite this expression. But remember, I had to add it to both sides. So let's start. We'll go x squared plus 4x plus 2 squared, because this is what I've added, plus 1 equals, and now it's 0, but I had to add the 2 on the other side to balance it out, because now these two things will cancel. Another way we could think about it, which is the way that I prefer to write it, because it seems more obvious at the time, is you write the plus 2x that we've added, but straight away you subtract, 2x, the 2 squared, but straight away you subtract the 2 squared again. So really, we've added 0. So we're really clearly seeing we're not doing anything to the expression. Then I tack on the original plus 1 equals 0. Now what I want to do is rearrange and expand and move some things around so that it looks like a perfect square. So if I write it as x squared plus 4x plus 2 squared, so far, in this case this is nice because I can see, remember I wanted an a squared and 2ax, so I can see if a is 2, this is 2 lots of a, so that works. But what about all the other junk? Well, let's just move it to the other side. So the minus 2x will change, the minus 2 squared will change to plus 2 squared because we've moved it over. And the plus 1 will move over to be minus 1. So now what we end up with is x squared plus 4x plus 2 squared equals 2 squared is 4, minus 1 is 3. The whole reason we've done this is because this is now a perfect square. A equals 2, 2a, or 2ax equals 4x, which we've got, and we've got. That was the goal. That's what we were trying to achieve. So therefore, now that I've got that, I can now factorize. I can go straight away using the perfect square rule. That's x and x. Remember, it's over here, two numbers that multiply to give this, which in this case is 4. So if you wanted to expand it, you could leave that as a 4 and go two numbers here that multiply to give 4, but they add to give this. So what are we going to have? So if we have 2 and 2, and we can check it. Do a quick FOIL. Both plus. Do a quick FOIL. We're going to have x squared from the first term, outers plus 2x, inners plus 2x, so we get 4x. Great. The lasts, we're going to get plus 4, which is good because 2 squared is 4. And that equals 3. We're close. We're almost there. The next step is to say, well, let's put these together because this is just the same as x plus 2 all squared equals 3. And now what we want to do is we're actually trying to solve, remember? The whole point of this is we're trying to solve. So what values can x have? So we've got x plus 2 all squared equals 3. Let's look at that. X plus 2 all squared equals 3. We take the square root of both sides. So x plus 2 equals square root 3. And the trick here, this is sort of a little bit new for us, it's not just square root 3. We actually have to write plus or minus the square root of 3. Why do we do that? Because if you think about it, that 3 when we square it, if it's a minus 3 squared is plus 3, because it's a minus times a minus. So it could actually be a negative value, but we don't know, because when we square it, we've deleted that negative. So when we go backwards and we go, well, if you ever square root a number, it is technically plus and minus. Previously, we've ignored that completely. We've just said it's always positive. But now, particularly in this section for quadratics, it's actually really important, because the plus and the minus can A, give you two different answers, which we'll see later why that's important, but also you can have a negative answer that will make perfect sense. So that's our first step. Now all we're going to do is move this to the other side. So that's going to become x equals plus or minus square root 3 minus 2. Which means you've got two answers, and that's completely fine. So either x equals plus root 3 minus 2, or it equals minus root 3 minus 2. And these are our two answers here. So if I reveal the solutions, this is exactly what they've done. So I just went through it sort of step by step with a bit more detail, but this is what they're doing in the solution. So you can see they've done the plus b squared on both sides, or if you prefer my method, do plus 2 squared or plus b squared, and then subtract it straight away. Then they've condensed it, done exactly what I've done, plus and minus the square root of 3. Then what are your two options? You could just write exactly as I wrote here. That's okay. That is covering both answers. You don't actually have to write the individual two options, because at our level mathematically we know what that means. So that's perfectly clear. So for the second example, the only difference here is we've got a negative 3x here. So A, the first example was monic, B, second example is not monic, and lastly there was a negative there. So what's going to change? If we add a negative and a non-monic, what does it look like? So what have we done? Firstly, we divide both sides by negative 3. Let's get rid of that negative 3. So that's what we've done in this step here. We got rid of it. We obviously had to change the numbers and the signs because we're dividing by a negative. So minus 4, minus 5 on 3. We've done the 4. We've done the same process. 4 is 2 squared, so we'll add 2 squared to both sides, or you can add 2 squared and minus 2 squared. We've then gone from here, so everything else was just moved over, that's what this was. The 5 on 3 we just got rid of, because that's useless. From here, we've then just said sweep, so 2 and 2, or here we can go, this is a squared, this is 2a, so x minus 2 all squared, because remember it's a minus. And you can check it. You can go, these two minus and a minus gives me a plus. Minus 2x plus minus 2x gives me minus 4x. Great. Equals 17 on 3. Follow the same process. Plus or minus the square root. Move the 2. You get your solution. So this is solving a quadratic equation through completing the square process. There are some worked examples here. Again, this is from the other textbook, so they do it slightly different. They're really emphasizing this b on 2 process, whereas in the other example, they're not explicitly writing b on 2. They're just saying take the coefficient of the x and find its perfect square. So if it's 4, obviously it's 2 squared. If it's like 9, it's 3 squared. So that's the process. So there's some worked examples here if you want to follow through the slightly different way for a couple of different examples. Same thing with this one. Completing the square if possible. So we want to check, can we actually do it? In this case, it's not a difference of perfect squares. So we can follow that process. Didn't work. We can't actually factorize any further. And then similar, this is exactly what we saw back here. Factorize when we've got a fraction. So when this C value, remember this is A, B, C. When the C value is a fraction, what do? Doesn't really change too much. We're still using that b on 2 process. The trick here is that 3 is not a nice easy thing to do. You go, well, how do I do like a square rooty kind of thing? Well, we don't need to, because remember it's just the b on 2 all squared. So it's just 3 on 2 all squared. Leave it as a fraction for as long as we possibly can, and things will work out. The only difference is you get sort of a bit of a gross value, things like this. So we're getting like root 7 on 4 all squared, but that's okay. That's just using surds, these square roots, within our question. So let's have a go at some practice. So I'm going to say, Let's do first column, second column, and same process applies. If you make a mistake in any of these columns, do the next one to it. In fact, do 2. Let's do a 1 to 2 ratio. If you get 1 wrong, you have to do 2 to make up for it, for every mistake you make. Solve exactly by completing the square. Let's do the whole bottom row. And solve for x, let's just do all of that. So these are the questions I want you to have a go at for this section. Solutions are in the next slides, and I apologize for the quality of this. This textbook only came with full work solutions for most of these questions, and the resolution when I scanned it in was really low. So I apologize. Hopefully you can actually see what these little solutions are and you can follow it. But I liked that at least it gave you the full step-by-step rather than just giving you an answer. So if you do make a mistake, it's easier to see where you went wrong. The next section, decide what number must be added to complete the square, then factorize. Let's do all of that because that shouldn't take too long. Same thing again here. Let's just do these 2 columns. Factorize by completing the square. Factorize if possible. So let's go C, and in fact, let's just do the last 2 columns for those 2 questions. So 3 and 4. And solutions are on the right hand side if you want to check, which these ones aren't the worked. They're just the final answers to check. For question 10, we've got a non-monic quadratic, such as they've shown that it can be factorized using this method. Notice this little point here. 5 on 2 divided by 2 is 5 on 4. So if you're not really sure how that works, check with me. I'm happy to go through that. Use a similar process. So try and mimic this process and try and factorize these questions. So this is certainly a tougher version of it. There's some more complex fractions going on in here. But have a go at these ones. If you really struggle with this bit, I'm not too concerned because this is certainly a more challenging type of question. But it's a good practice to really try this method, especially because we've got lots of fractions and things like that. So there is a progress quiz here. So if you are a little bit ahead, this is sort of an optional add-on. Do these questions as a quick check. So far, this is what we've covered. Simplifying and expanding, factorizing, completing the square. So these are some good questions to check where we're at. There aren't solutions to these. So this would be a good opportunity to just check with someone next to you. Maybe you go through them together and just compare your answers as you go. But it's an optional little progress quiz if you just want to check how am I going with all the content we've covered so far. So that's it for today's lesson, and we'll continue in the next lesson.